Welcome to today's session. This is still Unit 5. This is Lesson 21. It is Session 1 and 2. So we are going to start looking at equations, whereas before we were looking at expressions with Lesson 19, which was the last lesson that we did. And we want to look at one variable equations today. So first we need to decide, okay, what is an equation? Well, there are some differences between equations that we need to specify. So, first off, examples of equations. So, we could have something like x plus 2 equals 7. That is an equation. And you've been doing something similar to that since about probably kindergarten age, where you would have seen a square and a plus, and they might have had two circles, equals, and then 7 circles. And then you had to decide, okay, how many circles plus 2 circles will give me 7 circles. Um, so that's a skill you've been working on for a while. And most of us, because of that, can do this in our head, right? But I don't want you doing these in your head. And the reason why I don't want you solving these in your head is because there are some steps and things that you need to learn about equations. So, with equations, we have some things that we need to decipher from expressions. So, if we have an equation, we will typically be looking at something a little more simplified, such as x plus 7 equals 12, something like that. That equation is what we would call a balanced equation. And when you're thinking of balanced equations, you can think of it like a seesaw on a playground. If you've ever played on a seesaw, in order for both people to get on each side of a seesaw, you have to even it out, right? And then if one person moves, then it becomes unbalanced. So you have to do the same thing to the other side of the seesaw to balance it back out. So that's exactly what we want to do with equations. And when we're working with equations, what we need to know is that both sides of the equation, this side, the left, and the right, are each expressions. So we want to define equations right here. And equations are equal expressions. So that's one thing we need to know about equations, that they are equal expressions. We also need to know that with equations, we can find the value or solve for the variable. In this case, we can find the value of this 8. Sometimes the problem will say find the value of the variable, other times it will say solve for the variable. It means the same thing. So we need to know that equations are equal expressions and that we can solve or find the value of our variable. And some examples, we'll stick with the one over there in the corner that is an example of an equation. We could also have subtraction. This is a z, by the way. Z minus 3 equals 9. That's an equation. Or we could have something that's a little more complex. We could have something like 2 times x plus 3 equals 24. That is an equation as well. So that's what equations are. Just a little brief mini introduction here. All right. This next part is something that you've been doing since fifth grade math. Taking a word problem and creating an equation from that. So the first one says Martin is collecting plastic jugs for a recycling project. He receives 6 from his neighbor, and he receives some, which we're going to use J for, from his friend. He has a total of 10. And then it says how many jugs did his friend give him. Now, note, we are creating an equation for the following. So that's what we want to do here. With this particular equation, or with any equation, we want to look at, okay, what's our total? Well, our total in this case is 10. Well, how are we going to get to 10? He gets some from a neighbor and some from a friend. Well, he got 6 from his neighbor and an unknown amount from his friend. So now we have an equation of 6 plus j equals 10. The next problem says Kathy sold 25 candy bars. She sold Butterfinger bars, which was an unknown, and 10 Snickers bars. Now again, we can look and we can say, okay, what's the total here? The total is 25. Well, how are we getting to 25? She had an unknown amount of Butterfinger bars and 10 Snickers bars. So then I can solve for B, and I have an equation for that word problem. So we want to be able to do that. Again, that is a review skill, but I know that some of us will need practice with that. What we want to be able to do is take that and follow some steps to find the answer or find the value of our variables. Again, most of these you could do in your head, but I just don't want you doing them in your head because there's some specific skills we need to acquire with these. So in your curriculum, they use what is called a hanger diagram for equations. This over here on the right side is a hanger diagram. You will notice that there are boxes with the number 1 inside of them. And then there is a triangle with a Y. Those are each separate terms. If they are the same shape, they are a term. Okay? So for this, it's all one term. They're all the same shape. And there's 1, 2, 3, 4, 5, 6. 6 boxes. So that's 6. And then where you see this line where it's divided, that's like the tipping point that equals. All right? So if we're thinking of that seesaw, this is the left side. And then now we're ready to look at the right. The right has 2 different shapes, so it's 2 different terms. The first term is y. There's only one y. Plus, there are 2 squares, each with a positive 1, so that's plus 2, because that's 2. 1 and 1 is 2. So that's the equation that is formed from this particular hanger diagram. Now, I can use this diagram to move some things and figure out what y is. And I can do that if I could just get y by itself. So if I want y by itself, I can take away 2 boxes over here. So I subtract 2. Then I'm left with only y on this side. Now, I've done something over here. So now my equation is no longer balanced until I do the same thing on the other side. So if I subtract on one side, I have to subtract on the other side. So now I have 6 boxes minus 2 leaves me with 4. And that's the skill that we need to be acquiring. That we need to be able to look at this and we need to be able to say, okay, so I had a plus 2, then I subtract 2. And if I do that on one side, I have to do that on the other side. So we want to get that skill of being able to do the opposite operation, because the opposite of addition is subtraction, and then to also know whatever we do to one side of our equation, we must also do to the other side. Otherwise, it's unbalanced and it's not true. It's not a true equation. So, to find the value of a variable, we can perform the opposite operation, opposite of addition, subtraction, do the same thing to the other side, and get that variable by itself to find the value. So I do want to change something here. I do want to change this to plus instead of minus, all right? And this time you're given an equation and we want a hanger diagram. And we're going to use that hanger diagram to solve for the variable, for the value of the variable. Okay, so if I have a hanger diagram, my line goes here with the equals and I have my left side. Well, on the left side, I have the variable b. And b is a term by itself, so it gets its own shape. So I have b, and then I have 2. 1, 2. And you can put the number 1 inside of those if you want to. It's not something that I would require of you. So we have 2 circles because that term is itself, right? So we have 2. And if I used circles to represent my constant on the left side, then I need to use circles to represent the constant on the right side. In this case, we have 9, right? So we want 9 circles. 2, 3, 4, 5, 6, 7, 8, 9. So now I want to get b by itself. Well, right now I have plus 2, but if I take away 2, then b is by itself. Now, I have an unbalanced equation at this point, so I'm going to have to take away 2 on the other side. So once I do that, 9 minus 2 would give me 7. So now I have found the value of b. It's 7. My next one, I have y plus 4 equals 10. I want you to try that one on your own. And if you have questions, message me or ask me when you get back to school. But I think at this point we should be able to get y by itself by using this diagram. All right, the next problem has the hanger diagram. And you're going to find the value of x. So you want to get x by itself. I can take away 3 boxes. Since I have taken 3 away from the left side, I want to do the same on the right side. So I'm left with x over here is equal to 1, 2, 3, 4. X is equal to 4. Next problem says an animal rescue group in Africa is taking care of 5 injured baby pixie frogs. They plan to release them back into the wild when they are healthy. Each pixie frog needs its own terrarium. One of the rescue volunteers checks and sees that there are only 3 terrariums. Create an equation to find how many more terrariums T the rescuer needs. Find the value of T. So I want an equation. And if you remember before, we said, okay, we need to figure out total. Total, they need 5 terrariums because each frog gets its own, right? They have 5 frogs. They have 3. So 3 plus some more will give us the 5 total that they need. So we have created an equation. And there's 2 ways that we can solve this equation, that we can find the value for t. We can use a hanger diagram. And remember, our original equation was t plus 3 or 3 plus t, it can be written either way, equals 5. So the goal is to get the variable by itself. Right now, I've got plus 3. But if I subtract 3, that leaves me with t. Whatever I do to one side, I must also do to the other side. That leaves me with 2. So I have subtracted 3 from both sides and found that t is equal to 2. Now, the other way to do this is the way that we need to get more comfortable with. The hanger diagrams are great when you have small numbers and you can draw, the different shapes and everything. But they're not going to be so great if you have larger numbers. Anything really over 10 is not ideal to use a hanger diagram for. So, instead of putting the shapes underneath here, instead I look at my equation and I say, okay, right now is this side, this expression, because remember, an equation is two equal expressions, right? So this expression by itself is as simplified as it can be. Yes, there are no like terms. Then I look at the other side. Is that expression as simplified as can be? Yes, there's just one term sitting there by itself, right? So it's simplified on each side. Now I can start manipulating the side that has the variable to get that variable by itself. So right now I have plus 3, but if I subtract 3, then that would be 0, right? So I'm left with t. And whatever I do to one side, I have to do to the other side. So I want to say 5 minus 3. Well, 5 minus 3 is 2. So we do not have to have a hanger diagram. We just have to remember we want to make sure first that each expression is simplified. Then we look at the side with the variable and manipulate it to get the variable by itself. So, simplify, get the variable by itself, then whatever we do to one side, we have to do to the other side. We have to keep it balanced. So simplify, get the variable by itself, and keep it balanced. All right, in this problem it says Teresa has some photos on her computer on Monday. On Tuesday, she downloads 24 new photos. Then she deletes 9 photos. She ends up with 33 photos. Explain how the equation, and they have an equation there, represents the situation. Then solve the equation for the variable p and interpret the solution. So looking at this equation, she had some photos on Monday. We don't know how many. That's where p comes from. She downloads, that's adding 24, right? Then what did she do? Well, she deleted 9, so that's the minus 9. And then after she had some, added some, took away some, she was left with 33 photos. So that is where each part of the equation comes from. So now that we have our equation, we can follow our steps to solve for the value of p. Okay, I want to look at each side, each expression. Remember, this is an expression by itself. This is an expression by itself. So, when looking at this, can this first expression here be simplified? Are there any like terms? Well, there's only one p term. However, this plus 24 and this minus 9, neither one has a variable, so they can be combined together. So 24 minus, because that's what's in front of our 9, right? 24 minus 9 would be 15. And then we bring down the p, and this is a plus 15, equals. Now we need to look and say, okay, is this other side as simplified as it can be? Yes, it only has one term. That's as simple as it goes. Now we say, okay, I have simplified expressions on each side of my equal sign. Now I need to manipulate this so that the variable is by itself. And right now there is a plus 15. But if I subtract 15, that leaves only p over here by itself. And then I want to do the same thing to the other side. Subtract 15. 33 minus 15 is 18. So our value for p is 18. All right, this one I would like for you to try on your own. Remember those steps. Look at each side. See if each expression is simplified. Once they're both simplified, then manipulate to get the variable by itself and make sure whatever you do to one side, you do to the other. So do that one on your own. If you have questions, message me or ask me when we get back to school. And then I also want you to try the exit ticket on your own. You will have to come up with an equation for this one and solve for C. So again, try those last two on your own. If you have questions, please message me or ask when you return to school.